Bioethanol production from rice straw. For introduction, bioethanol is an alternative energy source to replace fossil fuels that can be produced from agricultural waste, such as rice straw. Rice straw is one of the most abundant lignocellulosic waste material in the world, and it is produced annually from 700,000 hectares of rice field in Malaysia. Rice straw can be used to produce 205 billion liters of bioethanol per year, or about 5% of global consumption. In this study, rice straw was used to produce ethanol using simultaneous saccharification and fermentation (SSF). SSF was used to produce ethanol by first liquefying and saccharizing the lignin, cellulose, and hemicellulose molecules of rice straw, followed by hydrolysis of cellulose that degrade polysaccharides into fermentable monomerate sugar. Steel tank bioreactor has been used in this production for enzymatic hydrolysis process. Complex media is a type of media used on this processing of bioethanol, as it is largely composed by plant, which is rice straw, and it takes cellulose as a substrate. During SSF process, the hydrolysis of the polysaccharides recovered from the pretreatment is the second stage in the manufacture of bioethanol after the biomass has been pretreated. The breakdown of polysaccharides in an aqueous media catalyzed by enzyme or acid is known as hydrolysis. Enzymatic hydrolysis of cellulose is a process in an aqueous media between cellulose and insoluble cellulose that tries to degrade polysaccharide into fermentable monomerate sugar. Cellulosic enzymes are utilized as catalysts in this process to break down bonds in cellulose to create glucose, which may then be fermented into bioethanol. The bioreactor must attempt to produce conditions for optimal conversion of cellulose to glucose with the least amount of enzymes. The bioreactor must ensure efficient use of the catalyst and substrates as refactor into glucose yield per enzyme and the amount of glucose per unit of cellulose, which are considered the most important variables to evaluate when designing for bioreactor for the saccharification process. Bioreactor for saccharification process must contain certain characteristics and variables, especially temperature, pH, and agitation. Sterilization. The fermented broth is centrifuged while the liquid part of the broth is passed to ethanol separation, and the yeast is reused for the next fermentation to achieve higher cell density. For conclusion, simultaneous saccharification and fermentation is a perfect process for converting lignocellulosic biomass into bioethanol. Bioreactors are crucial to ensure proper interaction between enzymes and substrates during the saccharification step. To promote cellulose bioconversion and make enzymatic hydrolysis an affordable process, an ideal bioreactor design developed that improves mass and heat transfer while consuming little energy. Enzymatic hydrolysis has been used extensively in conventional bioreactors, such as steel tank bioreactor. Thank you.